I want to start this lesson with the topic of trigonometry. Consider any angle you like. 30 degrees, 40 degrees, it doesn't matter. For sake of argument, let's say this is 30 degrees. If you pick any point on this side and draw perpendicular at 90 degrees to other side, you have created a right angle triangle which has got three sides. That side, which is opposite the 90 degrees, is called the hypotenuse. We call it hyp for short here. The side which is opposite the 30 degrees, called opposite, O for opposite. And the side which is not opposite or hypotenuse is called adjacent, A for adjacent. So we have hypotenuse, opposite, and adjacent. Now, before we actually begin topic of trigonometry, I want you to look at these lengths. If I divide this length by this length, is a trigonometric identity. That is known as sine of angle 30 when we divide this length by that length. If I divide adjacent by hypotenuse, that would be the cos of that angle 30. And if I divide opposite by adjacent, it would be tan of 30 degrees. Now the question is, could that point be anywhere? Yes. Let's have a point over here. As long as you draw 90 degrees. Now the new triangle, this is the hypotenuse, this is the opposite, and this is the adjacent. So if you divide this O by this H, the length of opposite by the length of hypotenuse, you get the same answer as you would do if you divide this opposite by its own hypotenuse. The same A divided by H in the small triangle would be the same as A over distance H in the big triangle. Let's do another one here. So these ratios are constant for a given angle. So in this big triangle here, this would be the side opposite minus 30 degrees. This would be the adjacent for the big triangle, and that would be the hypotenuse. So O, distance O over H, distance A over H, and distance O over A are all same value, the constants. Now, in order to make the understanding of this topic better and quicker, I advise you to construct three triangles with a letter T inside. And the letters that go into here is based on what I've told you. The sine of the angle is opposite over hypotenuse. So S for the sine, O for opposite, H for hypotenuse. The cos or cosinus of the angle is adjacent over hypotenuse. So C for cos, A for adjacent, and H for hypotenuse. And T, which is the tangent, is opposite over adjacent. The good thing about these triangles is if you're looking for S, you know what to do. If you're looking for H, you know what to do. And if you look for O, you know what to do. If I'm looking for S, I cover S and it would be O over h, as you can see, O over h. If I'm looking for h, cover h, you see O over S, just cover h. And if you're looking for O, because O at the top and S and H are the same level, we times them. Here, C, if you cover C, you have A over H. If you're looking for H, cover H and it's A over C. And you're looking for A, is C times H. T, O over A, O over T, and O is T times A. So let me remind you again what these letters mean. O, opposite. Opposite to the given angle or the required angle. With the examples to follow, you understand what I mean by these sentence and these words. A stands for the adjacent to the angle. H, hypotenuse. Hype for short. Now, S, C, and T are the trigonometric terms, trigonometric ratio. So sine means the sine of the angle. C is the cos of the angle. And T is the tangent of the angle, or tan of the angle. So S for sine, C for cos, T for tan. I'm not going to go through 9 examples which completes the whole trigonometric topic. Example 1. The type of question you will get which involves trigonometry. So I give you a certain triangle. Oh, yeah, of course, it has to be a right angle triangle. I give you this angle to be 40 degrees. And I'll tell you this length is, say, 5 centimeters. And I'm asking you to find the size of this length. With one side, one angle, you can find the other side of the right angle triangle. You need to label. Based on the given angle, you need to label. So, because 40 is here, opposite to 40 is called the opposite. So that 5 centimeter represents O, or opposite. You can trace the arms of the angle. That's the vertex. Opposite is the side at the end of the 2 arms of the angle. We all know from Pythagoras that the side opposite the 90 degrees is hype, so I'll call it H. The side which is not given, not needed, do not label. Do not label A, although it is A. The reason for this is you're looking for 2 letters to identify which triangle you want to use. Is it the first one, which was sa, or the one, 'K'. 'K' or the one which was toi. You need to remember sa, ka, toi. This expression got to be learned. So when you go to an exam, knowing you're going to have a trigonometric question, you need to construct this before start. So I'm looking here. Which two letters appear in any of these triangles? Or which triangle has got O and H in it? C got A and H, T got O and A, S has O and H. So I'm looking for SOH. Once you identify which triangle you're looking for, the triangle does it for you. I'm looking for H. So from here, H equals, cover H, and it tells you O over S. Let's replace. H was labeled as X. O is 5. And S is a word starting with S, which is sine of the angle. Sine of the angle 40. You can't just say sine. Sine of something, sine of certain angle. And after this, you just enter the calculator. So here you make sure that your calculator is in degree mode. At the moment, if you look, it says R, which is a radian, and we are not interested in that. So I'm going to change to degree mode. So degree mode is 3. And you can see the R up here is now changed to D. So always make sure you calculate on D mode for simple trigonometric questions. Okay, now I'm going to enter 5 divided by sine 40. Close the bracket before you press the equal sign. For some reason, calculator gave me error. 5 divided by sine 40 degrees. I think I didn't put the cursor outside. So it tells me that side is 7 point, if I round to 2 decimal places, it would be 7.78 centimeters. You can see the hypotenuse, which is the longest side, is greater than 5. Something that got to be really wary about. If that number came to be less than 5, you know something's wrong, because you can't be shorter than the longest length in the question when you do trigonometry. Height is the longest side. Now, let's go to example 2. Let me change the orientation of the triangle. So this angle is, say, 43 degrees. And I'm looking for this side, the hypotenuse given, say 3.2 meters. Okay, whether I'm using sine, cos, or tangent depends on what information is given to me in the exam and what is required. We all know opposite the 90 degrees is hypotenuse, so H is involved. Opposite the given angle is called opposite, so that's O. So again, I've given you a question which involves O and H, like the first example. So we go O, H, therefore I should be looking for a triangle with a T inside, which has O and H in it. And it's the first one, SOH. I'm looking for O. My O is unknown. X is my unknown side, which is labeled as O. To find O, you cover O. So O equals S times H, because S and H are the same level. All you have to do now is substitute for O, which is x, substitute for S, which is the sine of angle 43, times H, which is 3.2. The rest done by the calculator. So here we go. You enter sine of 43. Make sure you close the bracket. Times 3.2 equals. So we have 2.18 meters. So I found this side, which of course is shorter than the hypotenuse, the longest side. Coming to example 3, example 3 has one extra step. Whenever you're looking for the angle, there's an extra step that you need to learn, and that would be similar for when you do cos, tangent, same procedure. So let me again change the orientation of the triangle. Got 90 degrees here, and I'm trying to find this angle here, the size of the angle. And say for sake of argument, I say this is 2.5 centimeters, and this is 5 centimeters. We need to label again based on the angle and the sides. That doesn't need any clarification because opposite the 90 degrees is hypotenuse. And opposite the required angle or given angle is opposite. So again, I designed the question which involves O and H. So O and H again will take me to triangle SOH. So, the very first one. Then you write SOH from bottom left, top bottom. Now, which of these three letters am I looking for? Am I looking for H? No, H I have. Am I looking for O? No, O I have. So I must be looking for S then. So how do I find S? But the triangle tells me how to write it. Cover it. So you have O over H. Now let's replace. So as you can see, once you identify the sides of the triangle does the question for me. S represents the sine of the angle which I don't have. It's the required angle. Sine of x. O is 2.5 and H is 5. I don't need to really calculate this. I haven't found the angle x. I've found the size of angle x. But I wanted the angle. So somehow I need to get rid of the symbol of sine here. To get rid of sine, you have to do an operation which called opposite to it. It's called the inverse sine. I'll go through the rituals here and I'll tell you what extra things you shouldn't be writing. So what I'm going to do, I'm going to reverse sine. This is a symbol of reversing sine. Sine with a symbol of like a -1 is not a -1, but it's the symbol for undoing the sign. So I'm going to do that on both sides, on this side and that side. It's got inverse sine of sine of x is inverse sine of 2.5 over 5. And what I said, inverse sine undoes the sine. So inverse sine cancels sine. You're left with x. And that is inverse sine of 2.5 over 5. So you don't need to show this section. So you go straight from there to there. Just think of moving the sine from this side and put it outside the fraction on the other side. Remember to put this symbol on it. Question is, how do I access that symbol on the calculator? If you look here, locate sine. We cancel the information already on the calculator. Look at sine. Above it, in gold, written sine minus 1. That is inverse sine. Arc sine, some people call it arc sine. Means exactly opposite to the sine. So to get to that gold function there, I need to start the shift function first. Shift sine. And you can see the calculator printed for you sine minus 1 or inverse sine. All you have to do, enter the number that you want to find its inverse sine. So it will be a fraction, 2.5 at the top, 5 at the bottom, and now press equal sign. And it tells you that angle was 30 degrees. So you found that particular angle. That's the answer to this question. If you have a 30 degrees here, the opposite would be 2.5, and that would be 5. Okay, I'm now going to talk about the next three trigonometric ratios.